So hey guys, welcome back to another video. Today's topic is code obfuscation. Code obfuscation होता क्या है and why does it matter whenever you try to deploy your application on prod, or basically you are launching your application. So in that kind of situation, you must remember this term code obfuscation, what it is, what does it do, how does it help you to make sure that your code is protected from cyber attacks and those kind of things. So let's dive into this. So first of all, what is code obfuscation, what it is, why it exists, how it survives contact with the compiler, and what it actually costs you. Let's understand this using diagram, not just definitions, right? So ये होता क्या, right? What is code obfuscation? The definition of code obfuscation is it is the process of transforming source code into a version, source code, or you can say compiled code, into a version that is very hard for human to read and understand. So basically we are making sure that any other human or whatever AI tools that are there in the market that don't understand our code or what we have written, so that they cannot understand. Of course, if they don't understand, they cannot reverse engineer it, right? So code obfuscation is basically it makes hard for you to reverse engineer anything that you have built, right? So while making sure the program still does exactly what it did before. So the basic definition, so it transforms source code into a version that is hard to understand or reverse engineer, right? Now think of it like translating a simple recipe into deliberately confusing round about language. The reader could still cook the dish if they worked hard enough, but it would take much longer to figure out the steps, right? That's obfuscation. It hides the food, it hides the recipe's readability, right? If you have created a dish, it won't hide what is the end thing, which is the dish, but it would hide the steps which were required to prepare that dish, right? So you can understand it in that way. Now let's understand by example what code obfuscation is. So let's understand through this example what code obfuscation is. So as you can see, here is a function calculate bonus salary, let bonus rate equal to 0.15 and salary is into bonus rate, right? Whatever there would be. Now when we use obfuscator, there are like many tools in the market that you can use. I will show you in the end what are those tools. There are free libraries as well which you can use for JavaScript. Of course, there is JavaScript of obfuscator. So what it did, it renamed this calculate bonus to some this kind of string, and it renamed the variable name salary to this kind of string, and the other variables as well, and these as well, right? So 0x2 is same as this, right? But it did not reveal the actual variable name. So same math, same output, two very different reading experience, right? There is same math involved because compiler does understand these kind of values, right? Humans cannot. So same math, same output, two very different reading experience. Those underscore 0x hex style names aren't random. They are default output style of the popular JavaScript obfuscator tool. Spotting them in the wild. So spotting them in the wild is a good hint. You are looking at obfuscate JavaScript, right? Even if you see many website, right, like Udemy or any other website, you try to go to inspect and you see their code, you won't see their actual value like this. You will see this obfuscated value because it is hard to read and it is hard to reverse engineer, right? Now why do people obfuscate their code? What is the reason behind? One I told you reverse engineer, those kind of things, right? Now let's understand what are the reasons why do people obfuscate code, right? Now let me define some few reasons which are the main reasons, and what it project against. All right, let's create a table here. Okay. Now the first reason is IP protection. Why IP protection? It stops competitors from copying your unique algorithms and business logic, right? It doesn't allow to copy algorithms and unique logic. Your IP is protected. Whatever unique product that you have built is protected because the algorithms and unique logic, there are many algorithms for obfuscation, right? There are many ways to do it. I will explain you which. Why it is done? Basically to protect your IP. Second is security hardening, right? How it makes security harder? It makes it harder for attackers to find vulnerabilities or inject malicious code, right? Because code is obfuscated, attackers won't see variable names or other functions names, so it will be hard for them to inject malicious code, right? They cannot inject malicious code. Now client side exposure. Web and mobile apps ship code directly to the user's device, right? Web and mobile app ships directly to user's device, right? So anyone can open it and look. But obfuscation raises the bar for casual snooping, right? If people are just looking and they want to inspect and do something around those websites, so obfuscation makes it harder for them to do using inspect kind of things, right? Obfuscation raises bar for casual snooping. Okay, so that was about the reasons why what it project against: IP protection, security, hardening, client side exposure. Okay, those were the thing. The same technique get misused to malware. Authors obfuscate their code too, right, to hide it from antivirus scanner. Like you might be aware that even if this obfuscated, these things are fine, but in Amazon what they do, they hire hackers or security guys, and ask them to hack their own website Amazon and find vulnerabilities, so they can make it more, so they can make their security more harder. Now these guys are not common guys, these are from IIT Delhi, IIT Bombay. These guys are hired for breaking their system. So that's why you don't see you don't heard a news about Amazon getting hacked at any day, right? Because they hire smartest people to hack their system, and then they prepare for it, that how they can secure this system, right? So those kind of things exist. Now how does it survive contact with a compiler? Now you might be getting a question that we have obfuscated code, or we have uh, encoded or decoded these kind of regex patterns, right? Not regex patterns, but basically it is kind of encoded strings, right? Now how does it survive contact with compiler? Next, how does it survive contact with compilers? A common beginner question is, if you scramble the code, doesn't the computer get confused too? The answer is no. And let me show you in diagram why. A human and a machine are looking at two completely different things, right? For human it might be confusing, but for machines it might not. Now as you can see here, this is the source code, which is the calculate bonus. This is the obfuscated code, right? Now human reads this confusing, slow to parse, right? If they read this, right? Now machine reads this, which is obfuscated code, compiler, interpreter, and the basically it converts this to numbers, right? These are 1 and 0 1 0 1 kind of binary code, right? So machine reads this, names are already gone, logic unaffected, right? Names are not there, this is just a encoded string, right? So same syntax rules in, same instructions out, only labels change. Here what we have done, we just change the label, which is calculate bonus, to some kind of a encoded string, right? Now obfuscation only touches the layer humans read. By the time code is compiled or interpreted, variable names are already gone. A computer never cared whether something was called salary or underscore 0x1f3c, right? Computer doesn't care about it, because at the end it will be converted to binary, right? So yeah, that's why matter whether you obfuscate your code or not. It doesn't get your code slower. By the way, there are techniques which gets your code slower. There are obfuscation technique. The most basic which doesn't get your code slower is this variable name change. There are many other techniques which does slow your code. I will tell you about those as well. Now three reasons this works. Three reasons why this works is: syntax rules are preserved. An if statement is still an if statement, only labels and structure change, not the underlying logic, right? So if statements are still if statements, switch statements are still switch statements, right? Only the underlying logic is not changed, only the labels and structure is changed, right? Now second is, computers don't read names the way humans, right? Humans might read this calculate bonus and they might get an idea that this function is called for calculating bonus, but computer doesn't care about that, right? Names become memory addresses or numeric references before anything runs, right? As you might be aware of, if you have seen heap memory, how it works, right? You might be aware of how these variable names are stored in heap and how they are called, right? So that kind of thing. So computer doesn't care about variable name, see variable name as human do. So computers don't read names the way. Third is, it's not encryption, right? Nothing needs to be unlocked first. If you see this thing, right, this is not an encryption. It means that we are storing some kind of key like we do in login, right? We don't, this is not an encryption. We don't need to unlock it first. It's more like an essay written in needlessly complicated language, annoying but still directly readable by the one reader that matters here, and that is the machine, right? This is basically to serve the machine. If machine understands, it works for us, right? Now the 6 common transformations for obfuscation. Now the 6 common transformations for obfuscation are these 6. Identifier renaming. It renames the variables, functions, classes into meaningless characters, right? This is what we just saw. Analogy is labeled folders, random numbers, right? This is the analogy behind it. Now second is control flow flattening. What it does, it restructures loops, branches into a tangled shape, often one giant switch, right? It's a straight hallway, maze, same exist, right? So it kind of restructures your loops. It kind of restructures whatever logic is there, right? Not logic, basically logic stays intact, but the loops are restructured. It transfer if to else, if to switch and switch to if, kind of while, those kind of things, right? Often one switch, right? Dead code injection. Now what is dead code injection? Dead code injection, what it does, it inserts fake code that does nothing but confuse analysis, right? Dead code injection is pretty, by name itself it says we inject the dead code which does nothing. It's just sitting there ideally, but it confuses the end user, which who are reading the code. They might try to figure out what this code does, but it does nothing. They don't know that. So decoy rooms leading nowhere, right? Analogy behind this is this: decoy rooms leading nowhere, right? Now string encryption. What is string encryption? Encrypt sensitive text, decrypting only when needed, right? So what it does, it encrypts. Now this is the part what is string encryption. What it does, it encrypts sensitive text, decrypting only when needed. So we have the key to decrypt it. We can decrypt it whenever needed. If you have front end and back end, you have microservice architecture, then you can use string encryption. You can encrypt, and the variable names, whatever function names or whatever value that is passed to the backend, they might have key, and using that key they can decrypt. So this is also a method. A note in a locked box opened on demand via backend, right? When you have a key, of course. So instruction substitution replaces simple logic with needlessly complex equivalents, right? It replaces simple logic, like you have written some kind of condition when this variable's value is greater than 10, only then go further. So you can replace it with some complex logic to make end user confusing, right? So writing 2 as this, you can write 2, right? But you wrote this. This is its resultant value is also 2, but the way of writing became different, and it might confuse the end user, right? Or the hacker that might be trying to steal your code or reverse engineer, right? Code virtualization, this is very important. It requires VM. What it does, it converts your code into a custom language run by a mini interpreter inside the app. It converts your code into a custom language which is run by a mini interpreter inside your own app. So what the analogy behind this is, instructions only your private translator understand. Your private translator only understand. We can dive deep into code virtualization, but let's not do that. This is code obfuscation video, so let's stay on it, right? Now obfuscation versus minification versus encryption. Let's check what it is. So obfuscation versus minification versus encryption. So what difference between these three terms, right? Minification, what minification does, it shrinks file size. By the name itself, it says it shrinks the file size, right? So that is minification. Reverses in seconds. This can be reversed in seconds. Source maps, undo it, right? Hides nothing. This hides nothing. Minification is basically you are minifying its the whatever unnecessary things are there. You just remove it. You just minify the size. So minification hides nothing. What obfuscation does, it hides the logic, right? I am not sure if you can see this font, but it's written, this is obfuscation, right? And below that it is written restructuring logic plus names, right? It restructures the logic plus names. There is no key required here, right? To run it. It hides the logic. So obfuscation hides the logic. What encryption does? Encryption converts to ciphertext. It needs a key to use or run at all. It hides data behind the lock. As I told you in the example of when we were seeing this code, not a code virtualization, actually string encryption, right? In that we saw that how we can use key to encrypt and then decrypt on backend, right? So encryption locks the data behind a key. Only the middle one is obfuscation in the sense this guide covers. So that was about obfuscation, how these are three different things: minification, obfuscation, and encryption, right? Now, does obfuscation slow down your code? The most important question, right? Does obfuscation slow down your code? So does it happen? Now it's entirely on which technique you reach for. Renaming is free, virtualization can be brutal, right? Now we saw the techniques, right? Renaming can be free, renaming, because machine doesn't care about renaming your variables, right? But doing virtualization is brutal because it requires extra memory, extra space kind of things, right? And it can be brutal. Now as you can see here, as you can see here, your renaming has 0% effect. Control flow 5 to 30%. String encryption 50% or more time it will take. Virtualization affects 500 to 2000% extra time. So rough orders of magnitude, not benchmarks. Actual number depend on the tool and the language and how what the affected code path is, right? So why does heavier obfuscation slow things down, right? Now modern compilers like V8, GCC, Clang normally optimize your code automatically, removing redundant steps, right? If you are using code compilers like V8, GCC, those have their built-in remove code optimization tools, which removes redundant steps, inline functions, unrolling loops. So heavy obfuscation deliberately scrambles the structure, which confuses those optimizers and stops them from doing their job. Okay? So when you use this heavier kind of obfuscation like virtualization, string encryption, control flow, what it does, it confuses those compilers, those optimizers, and stops them from doing their job. One exception worth knowing is renaming can occasionally be faster, right? Renaming can be occasionally faster, not just free. Android's R8 renames and strips unused code classes, so the app ships smaller and starts up quicker. Protection as a side effect of an optimization pass. Now, best practice is selective obfuscation. What is selective obfuscation? Just explain you. So, best practice is selective obfuscation, right? Obfuscation. Best practice is selective obfuscation. Now let me just show you. So this is the diagram which we can use, right? So application, these are modules, by the way. Let me just write module. These are also module M. So these are modules. This is license check, which is virtualized. So these modules have been renamed only, which is free. And this orange one, which is license check, is virtualized, which is heavily obfuscated. It's sensitive logic only, right? Now apply renaming everywhere since it's free, right? You can apply renaming everywhere. Like in application, all modules we have applied renaming because it's free. Reserve control flow flattening or virtualization for the new sensitive spots like license check. We virtualized it because it's the sensitive spot, because it can be attacked, or license, or people know logic behind license, they can crack it easily and use your application. And you might have, if you are building a AI application, you might have lakhs of bills, right? Bills for tokens that were used. So a license check, a proprietary formula where a small speed cost doesn't matter to the end user, right? Here, even if it's slow, doesn't matter because license is generated only one time during the lifetime, right? Not the lifetime, but at a certain period of time. For 6 months, one license can be valid. For 3 months, 7 days, whatever that your tool you are offering, right? Now let's dive into popular tools by platform. What are the there are already built market tools for these obfuscation, and those are pretty popular. Let me name few of them, right? Popular tools, right? By platform, let me just define by platforms. Okay, so let me define so here you can see according to the platform we have divided it. So for JavaScript, the most popular, the free one is JavaScript Obfuscator. If I show you, it has, I think, some 700,000 weekly downloads. JavaScript Obfuscator, yeah. See, npm library. As I told, it has 770,000 weekly download. This is kind of pretty popular, and this brain is crying because, of course, it cannot understand the code. Humans cannot understand the code. Machine would be laughing, right? Now there are also premium versions of it, which is Jscrambler, preemptive JSDefender, right? If you see, Jscrambler is the pretty popular one used industry wide. Even if you are deciding between JavaScript, Obfuscator, and Jscrambler, I would recommend you go for Jscrambler. This is pretty industry standard. Most of the companies use this, and I think they use this kind of what we just defined, selective obfuscation, which we just talked about, right? And so yeah, for .NET and C#, you can go for Obfuscator, right? Obfuscator is a tool, Confuser EX, right? There is .NET Reactor, Obfuscator Professional, if you want to go premium. Free ones are this one. For Android, Java and Kotlin, you can go for R8 ProGuard, and there is a DexGuard which is come into premium sector. Now let's see. So now let's see Node.js workflow. If you are working with Node.js, which I am, so what is the Node.js workflow, right? So there are source files, right? So there are source files, and which gets bundled, right? You can use npm and webpack. You can use webpack for this, or es build for building packages and distributing. Then what you can do, you can obfuscate the single bundled file, right? Then it can be packaged, right, in .pkg or .exe. Now this dashed box, which is this one, this is the optional thing, optional step. Heavy obfuscation can break dynamic requires require which are dot routes or ORM tools like Sequelize, Mongoose, that map class names to database tables. Always test before obfuscating. So whenever you obfuscate, make sure you test after that, because it is very important. Now obscurity is not security. This is the main thing. Obscurity is not security, right? If you are obscuring, security is not security. Now if you are thinking that if I obfuscate the code, then it will be secured, it's not the case, right? Obfuscation slows an attacker down, it does not stop one, right? This is the classic security through idea, and it's why obfuscation is treated as one layer of defense, not the whole wall, right? This is the one layer of defense. It just slow down the attacker, right? Now we can see it as like, let's suppose I just diagram here, Tango, right? If you see here, okay, so what I want to say here is, this diagram that I draw, this code shipped to the user, right? This is the code ship. This is the obfuscate to raise the effort required to reverse engineer your app, right? This is the diagram for that. For reverse engineering, it would be high. It never relies on it to guarantee that secret stays secret, right? It doesn't. You should not rely on obfuscate that secret stays secret. But yeah, code shipped to the user obfuscated, but decompilers like Ghidra, JDX, Jets, DNSpy get most of it back eventually, never truly secure, right? Now a server you control holds the private key, the final license check, anything that must stay secret. This is the actually secret, right? So this obfuscation doesn't means that your whole code is secure. So obfuscation has a hobbyist artistic side too. The International Obfuscated C code contest, there was this one contest which is IOCCC, has run since 4. This is just an interesting fact, by the way, challenging programmers to write the most unreadable yet working C programs they can, including code shipped like pictures or the that hides jokes in its layout. Some core idea done purely for fun. So there were earlier they used to hold this contest where you have to write a code which machine can understand, but humans cannot, and it might be hard. It should be very hard for humans to understand. Now the key takeaways from this video, right? What are the key takeaways from this video? Key takeaways from this video, right? The first one is obfuscation makes code hard for humans to read. It does not change what code does, right? Computers don't care about readability, so obfuscated code runs correctly. Obfuscation is not encryption. If you have that confusion, please make sure you do not. That obfuscation is not an encryption. That there is no key needed to unlock it. That obfuscation is string encryption, right? So there are different kind of obfuscation which you pick decides, right? Different techniques carry very different performance cost. Renaming is free, virtualization is expensive because it requires space. Obfuscate broadly with lightweight techniques, reserve expensive ones for your most sensitive logic, right? You can have selective obfuscation as well. You can use the tools that are in market, which is this one that we just saw, Jscrambler or JavaScript-obfuscator. Now, never treat obfuscation as real security. Keep true secrets on a server you control using the key encryption and decryption, right? So that was all about obfuscation and what it does, what it means, how obfuscation and encryption are not related, not same. What are the difference between those? And I also shared key takeaways from this video. So make sure to hit like and subscribe. We'll keep on bringing these kind of new videos to you on new topics, which will be easier for you to understand. So yeah, thanks.